The ground beneath Ethiopia is shifting in ways most of us only read about in geologic textbooks, and right now that slow-motion drama has suddenly moved into the news feed. Imagine a place where crust tears magma, finds new paths, and a land that once seemed permanent shows the first signs of becoming something else. That's the Afar and main Ethiopian Rift region, a triangle of lowlands and volcanoes where three tectonic plates meet, and where over millions of years Africa is literally being stretched apart. Who is affected? Local communities whose homes, herds, and farms sit on this restless ground, scientists who monitor earthquakes, satellite imagery, and gas emissions, governments and airlines when ash plumes cross borders, and anyone who wants a reality check on sensational headlines that ask whether Africa is splitting in two tomorrow. What's happening now is both ancient and immediate. In late 2024 and into 2025, seismic swarms and dike intrusions, long sheet-like injections of magma into cracks, moved through the Fintail Dauphin region, producing measurable uplift surface fissures and evacuations. These were not isolated blips, they were part of a sequence captured by satellite seismometers and field teams, a reminder that a rift can behave both gradually and in sudden bursts. The scientific response catalogs successive intrusions, with some events moving tens of kilometers and producing earthquakes that damaged infrastructure, forced evacuations, and opened visible cracks in the landscape. Those are the facts. Tectonic extension at rates of a few millimeters per year, punctuated by sudden magmatic episodes that can change the ground in months. This is geological work in real time, not an apocalyptic split overnight. Now look at the timeline and the how. How did these events escalate from quiet plates to dramatic surface change? The rift's lithosphere is thinning under tensional forces. Magma is sourced from deeper mantle upwelling beneath the Afar. Triangle exploits weaknesses and intrudes as dikes. Those dikes force the crust apart, locally producing earthquakes and surface fissures. Between September 2024 and early 2025, monitoring showed a chain of dikes propagating sometimes for tens of kilometers. Satellite radar and GPS detected centimeter-scale uplift and ground displacement that matched the seismicity. In human terms, the immediate signals are earthquake swarms, ground cracks appearing near roads and fields, and in some cases the need to move people away from hazards. Scientists who published prompt analyses framed these as classic rifting behaviors, slow extension, punctuated by discrete magmatic injections. When these intrusions reach the surface or interact with shallow magma chambers, eruptions can occur. That was the real-world risk. The intrusion episodes increased the probability of surface volcanic activity in the short term. Importantly, remote sensing and fieldwork gave authorities a chance to map hazards, advise evacuations, and monitor ash clouds that could affect aviation and distant populations. The 2024 to 2025 episodes are a live demonstration of how rifting translates from deep mantle flow to surface disruption. People asking, is this a warning? Need a careful answer, yes, but not in the sense of an imminent continental break or sudden global catastrophe. The East African Rift system has long lived. It stretches from the Red Sea through Ethiopia and Kenya down toward Mozambique. Geologically, the African plate is being pulled apart, and over millions of years that could form a new ocean basin. The direct short-term warning is local dike intrusions and volcanic unrest, warn of hazards to communities and of possible eruptions that can send ash and air routes, as recent events in November 2025 illustrated, when a previously quiet volcano in northern Ethiopia produced a large ash plume affecting aviation in the region. Those eruptions can be sudden, and their ash clouds can travel large distances, forcing flight cancellations and creating respiratory and agricultural problems downwind. The more actionable warning for policymakers and emergency planners is to treat the region as high risk, invest in monitoring networks, create evacuation plans for villages and livestock, maintain timely communication channels, and coordinate with international aviation authorities. For everyday people, the practical warning is to heed local advisories, understand evacuation routes, and avoid areas with fresh fissures or ashfall. The big picture message is not panic. The continent will not split into two continents overnight. But the rift is active, and when it wakes, it can produce powerful local impacts that ripple regionally. So what does this mean for longer-term geologic futures and for narratives that love dramatic timelines? Scientists measure rift rates in millimeters per year. The East African rift opens at roughly 6 to 7 millimeters annually in many places. That small number sustained adds up over millions of years. Geological research, including new dating of lava flows and volcanic deposits, refines our understanding of when explosive volcanism occurred in the Holocene and how frequently hazardous eruptions might happen in particular segments. The Afar region is a unique laboratory because it's a triple junction where the Red Sea Gulf of Aden and East African rifts meet. Their extension is focused and magma supply is high, which explains why we see both fissure-style basaltic eruptions and occasional explosive events in places that in human terms have long seemed inert. From a scientific perspective, recent studies document the patterns uplift, dike propagation, episodic eruptions, and surface faulting. From a societal perspective, it means cities, roads, and pastoral lands built near active rift segments need tailored hazard maps and resilient infrastructure. It also clarifies an uncomfortable truth: development often outpaces hazard planning, and the most vulnerable communities are typically those with the fewest resources to adapt. International aid and scientific cooperation can help, but ultimately local preparedness and credible information channels determine outcomes when the ground moves. Finally, what should we do now, and how should we tell this story without slipping into fear? First, keep science central monitor with satellites, seismic arrays, gas sensors, and field mapping. The 2024 to 2025 dike events show that real-time monitoring can inform evacuations and aviation advisories, reducing harm. Second, treat media headlines responsibly. Africa is splitting makes a good clickbait line, but the sober story is a complex interplay of mantle dynamics, crustal thinning, and episodic magmatism that plays out over decades to millions of years, with occasional locally devastating episodes in the short term. Third, support local resilience. Invest in early warning, community education, livestock protection, and ash cleanup resources. Fourth, recognize global connections. Ash and aerosols can affect air travel and atmospheric conditions far from the eruption site, so international coordination matters. In short, this is a warning in the immediate human safety sense, but not a signal that continents will separate next week. The challenge and the responsibility now are to translate geologic knowledge into policy and preparedness to support communities on the front lines, and to keep reporting that is clear, evidence-based, and focused on practical steps rather than spectacle. The rift will keep doing its slow work. Our choices determine whether people suffer needlessly when it makes sudden moves.